שלום, אני רונן דר, Co-founder and CTO of AI. אנחנו בפודקאסט של ה-MLOps community. איזה כיף להיות פה. Let's get started.
I want to know about your coffee drinking habits. Do you drink coffee?
I drink bad, strong, only black drip coffee. That is what I drink.
That's so
and
bad.
I drink too much of it.
Dude, I'm like the opposite end of the spectrum here. I drink coffee very rarely, basically whenever I'm traveling. And I like to go to those places where it's like the hipster place where the barista, you look at them and they've got just random tattoos all over the place.
Oh, no,
and most of them are pretty like ugly sketches. And you look at that person and you go, they're probably really into coffee. And I order flat whites with oat milk or almond milk.
Not for me.
If we could have two ends of the coffee drinking spectrum, diametrically opposed, we've got it right here. It's amazing we get along.
Somehow.
So today we talked with Ronen and Gijsbert. Hopefully I'm saying that name right, from Run AI. What'd you think of the conversation?
I thought it was a phenomenal conversation. Run AI is building a really cool product that basically helps with virtualization and resource utilization of GPUs. And my favorite part of the conversation was hearing from Ronen why they wanted to build this product and what it enables in terms of a future where GPUs and computationally intensive workloads around machine learning are as easy to deploy, run, and sort of engineer around as the day-to-day computational tasks we do on our CPU. And I thought that was so cool to hear about the whole big picture vision of that, and I think everyone listening will really enjoy it. What was your favorite?
Yeah. It's interesting you talk about that, like bringing the same ease of use to GPUs as CPUs. There's a cool thread in Slack right now that is happening from a blog post that Run AI wrote on our MLOps community blog that talked about when to use GPUs, when to use CPUs, and what the trade-offs, downfalls are of each. And that's got a lot of traction. There's a great conversation that's happening. I encourage everyone to check that out also. My huge takeaway from this was when a light bulb went off when Ronen was talking about how he wants Run AI, or he sees Run AI, the vision to be the operating system for your GPUs. And just like you have the operating system for your computer that you sit at home with, probably, or wherever at work, wherever you hang out on the computer, and you have your operating system there. He's got this idea and this vision for Run AI to be the operating system for your GPUs. And then I also like just getting into the nitty-gritty of Kubernetes and having him tell us like what some of those challenges were when you're trying to scale things on Kubernetes, how that looks. Like there's so much cool stuff that he talked about. He's so smart. And to be able to get to talk with him and like hear, why isn't Amazon just doing this? Why is this a hard problem to tackle? I loved his answers and his reason for that.
Yeah, so thank you so much to Ronen and Gijsbert from Run AI joining us. Ronen is their chief scientist. Gijsbert is a technical product marketing manager. Anything else you got to say there, Demetrios?
I'm just still in shock that you like pot coffee. That's like...
Dude, I don't just like pot coffee. I love pot coffee. I wake up in the morning for pot coffee for 16 ounces.
Dude, that's so wild. This is a coffee session, and we actually talk about coffee. So for all those naysayers that give us feedback and they say, you call it coffee sessions, but there's no coffee. Well, here you go. This is our coffee session right here. Let's get into this conversation with Run AI. And a quick tidbit, Run AI did sponsor this episode. So if you would like to check out more of their product and all the awesome stuff they are doing, you can find everything you need to know about them in the link below. And that's it. Let's talk with Gijsbert and Ronen.
Gijs, Ronen, thank you guys for joining us. Did I get that right, Gijs?
Very, very close. Awfully very good close. Yes.
You know, I think that's like... that should have been my yearbook quote. It should be on my gravestone, awfully close at anything he attempted.
Yes.
But we're not here to make jokes about me. We're here to talk about Run AI, how you guys think ML should be built, productionized, what some of the principles are that you've used to create your product. Let's start, Ronen. Can you talk to us about what Run AI's product is and what the different components are that companies can use?
Yeah, would love to do that. So maybe let's start with, when we started Run AI, right? So we started Run AI 4 years ago, early 2018. And we started Run AI where we saw that, there is a gap. We recognized a gap in the stack, in the software stack, in the AI space, right? We saw that that there is a new kind of a new field with the new workloads and workloads with new requirements, right? AI workloads, right? Training models, building and training models, and then moving them to production. So we saw that there is this new type of a way of of creating software and running workloads. So workloads with new needs. It's not microservices running on commodity CPUs. It's AI workloads, very compute intensive workloads. So we saw new field with new requirements, and we also saw from the other side that there is this new requirement for compute, a new compute coming in, right? So if we're going back to the to the ImageNet moment in 2013, the GPUs that enabled all these breakthroughs in deep learning, and in NLP and computer vision, all this new amazing stuff that you can do with neural networks. So it was enabled very much by those GPUs, which were new in the game for many people, right? So you have this new workloads from one hand, right, with new requirements, and then you're getting this new compute, which is really, really important for deep learning, for developing, for new models, right, creating those new breakthroughs. And we saw that there is this gap between what's needed for AI and what the software stack can provide, the software stack that runs on GPUs, on that new hardware. So we came to that to that place. We saw that there's new components, software components that are really missing, and we started there, and we've built what we call an operating system for AI, right? A software layer that runs on top of GPUs. We're really attached to Kubernetes and to cloud-native technologies, and we're bringing to the game a new software layer that enables much better use of the GPUs for a compute for AI. So we're bringing a new software layer that provides much simpler access to GPUs, to that new compute, enabling very efficient sharing of GPUs. And we'll get into the details of that, but in terms of components that we've built, we're really attached to Kubernetes and cloud native, and we can expand on what we're bringing to the game and how we help organizations really make better use of their GPUs, their compute for AI.
I really like that description. An operating system, a whole AI stack, as the way I see it described, built on top of GPUs. And that makes a lot of sense, right? Because in the past few years, it honestly has felt like the enthusiasm for the use of GPUs has not kept up with the engineering around GPUs, right? And it's just, everyone wants to use them. Everyone's going to Google Collab and buying stuff on the NVIDIA website every time that, they want to try and mine Bitcoins and stuff. But there's not a lot of engineering around it in a way that isn't just, hey, AWS saying, let's just throw on, an ability to add a GPU instance, and not as much sort of thoughtful engineering around the use cases, which leads me to my question. Gijs, can you tell us about what kind of companies come to you right now and are saying, wow, the Run AI platform, the entire suite of software tools you've built around GPUs really makes sense for our needs? What kind of companies are those, and what problems are you solving for them?
Oh, great question. So there are many different types of organizations in many different stages of where they are. But I mean, you mentioned use cases. I think that's a great one. I think, and I'll talk a lot about a couple of use cases. One of them is organization with a team of data scientists. We all know GPUs are limited in availability. They're expensive, so they want to efficiently share their GPU resources across or amongst the different data scientists that they have, the different teams they have, and I want to do that in a very efficient way without, let's say, bothering the data scientists with all these infrastructure and Kubernetes complexities. Right? They basically want to share GPUs efficiently across a team of data scientists. That's one use case, right? Really getting the most out of the GPUs. We sometimes say extreme utilization, but what I'd like to say is we hate to see idle GPUs because that's a very expensive GPU, an idle GPU. So we want GPUs to be effective. The other one is where organizations, larger organizations, have different AI teams across their organization, maybe multiple business units with different AI teams. They've all started to invest in infrastructure to support those AI initiatives, but they're not getting the most out of it. We refer to that as shadow AI, right? Basically, AI that's out of the scope of the IT organization. It's hard to manage because all kinds of different clusters and different types of hardware out there. So what we really help them do is centralize all those compute resources and letting them really efficiently, again, share all of those resources across different teams, different business units, and really allow IT to deliver that as a service to the data science teams. Again, removing a lot of the complexity and overhead from those data science and AI teams and moving them into the IT organization, making sure that data scientists just focus on data, building models, training them in a very, very efficient way. Another use case is where organizations they already started to build and train their models and they know how GPUs work, but now it's like the next step. And I'm pretty sure this is a very passionate subject for Ronen, so he might jump in here. But that's the inference piece of it, right? Taking them into production. I now have multiple models I need to take into production. How am I going to do it, and how am I going to do it in a very, very efficient way? Like you said, it's very easy to pull your credit card and get GPU resources from a cloud. But am I doing that? Is that efficient? Does that make sense? Is like cost, value, is that aligned? So there's many challenges there, really taking those resources and taking those models and taking them into production. So that's actually, so we already discussed, we're all the way from an organization that just has a team of data scientists to an organization that has multiple teams of data scientists, and the other one is really taking those models into production. So there's multiple stages of it or where an organization is in. The value we bring is, again, making sure those resources are available to the right people in a very, very easy way.
Got it. I see that sort of maturity level that you're describing with GPU utilization, abstraction of infrastructure, the same things that we see in cloud, you're bringing to with GPUs. But I'm curious, and maybe I'm just teeing this up for you, Ronen, because I'm thinking back to your background, the fact that you were an academic before starting this company. Why is this problem hard? Why is this not something that, Amazon or Google or Microsoft has just said like, oh, cool, this is just our latest service? Why is this something that it takes your team to build?
Oh, amazing question. so, so think on what has been done in the CPU world in terms of the software stack that runs on CPUs, right? In the last 20, 30 years, there was so much work done on virtualizing CPUs, on the stack that runs on CPUs and make CPUs much more effective, right? So you can think even just on Linux, like how much work is in Linux just in operating system servers, computers with CPUs, right? Like Linux can manage resources, right? Can manage CPUs, memory systems, disks, networking in servers on computers, right? So in terms of operating system, there has been done so much work, right, on CPUs. It hasn't been done on GPUs. Now, the state where GPUs are today compared to where CPUs are, right, CPU systems, there's an enormous distance, right? If you're thinking on the way of CPUs are being allocated today, CPU systems being managed and orchestrated, it's totally different than GPUs, right? Think even on your laptop, right? Even like a simple case like that. You have your, in your laptop, you have your, your CPU cores, your memory systems, the disk, even networking, right? And you have your operating system that manages everything, right? Whether it's your iOS or Windows, right? You have your applications, they are running and they are sharing all the resources in your laptop, right? And the operating system manages everything and orchestrates everything. You don't even aware of that, right? And now think about an AI infrastructure. Same thing, right? Same thing. You have a lot of compute, whether it's CPUs, GPUs, memory systems, right? Storage, networking. And you need like an operating system to manage everything. So right now you have Linux to orchestrate, right, nodes, right? Like orchestrate systems in servers, in nodes. And now you have this amazing new technology, Kubernetes, that brings like operating system capabilities to clusters of nodes, right? Like container orchestration, that's what you get, right? You have Kubernetes orchestrating containers, sharing all the resources in your cluster between those containers, managing everything. So much work has been done in that sense, right? And orchestrating a workload running on CPU systems. With GPUs, it's the gaps are totally not there, right? So today, the allocation, right, of how GPUs are being orchestrated and allocated, it's very static and an exclusive way. We can get into the details there, but think about it like when GPUs are being allocated today to containers, to workloads, to processes, it's static and exclusive. Meaning when an application starts to run on a GPU, that GPU is allocated to that container only, to that application, no matter if the application is using the GPU or not. So the GPU can stay idle for a long time because the application is not using the GPU, and other application cannot use the GPU. So things like that bring a lot of inefficiency and a lot of places where all the orchestration, all the resource management is being done not effectively, right? Think like if I'll compare it to CPU systems, think about your browser running on your laptop. It will take like CPU cores, and those CPU cores will only be allocated to your browser. Like no other application could use those CPU cores. So that won't be effective. So, in that sense, in the way GPUs are orchestrated, allocated, and shared between applications, between containers, between workloads that are running in a full cluster, today it's done really ineffectively because a lot of software layers are missing today. And we're coming in there and we're bringing a lot of technology and a lot of software to that place.
I think that this is such an interesting way to think about GPUs, because if you think about where we're at, I always like to place machine learning, just for my own intellectual interest and to keep me happy at work, honestly, in the context of broader technology shifts, right? And when you think about 5G, machine learning, GPUs, even things like crypto, the numerical intensiveness of everything, big data workloads, data warehouses, everything, the numerical intensiveness is just continuing to increase, right? I'm sure that you can say that in much more scientific and precise terms, Ronen, but the data intensiveness, the amount of compute, right? It just keeps going up, And you hear always about this Moore's law sort of diminishing returns, right? Where CPUs and
Yeah.
chips in general are not able to be engineered quite with as many low-hanging fruit advancements. But you have this increase in compute needs. And so when you think about that, the fact that the hardware isn't necessarily getting better at a cheaper cost as easily, but the needs are growing more intensive, you need creative. That's where software plays a crucial role in mediating the demand and supply. And that's what you're talking about here, which is what the vision
Yes.
for Run AI is.
Exactly. Exactly. And you're seeing right now, right? You're absolutely right. For one hand, compute becomes very important, right? The need for compute only increases, right? We see it with all the amazing breakthroughs that are being done today in the NLP world, right? With
Yep.
like training models on thousands of GPUs, on hundreds of TPUs, so more compute allows you to process more data, to train bigger models, to solve more complex problems with deep learning. So that's amazing, and that trend happened in the in recent years, and it will continue probably, right? Then on the other hand, you have this more law ending, right? And we see GPUs and specialized compute coming into the game, becoming more important, right? So application specific hardware chips that are more specialized to specific applications. We're seeing that again and again, right? So GPUs. So it's not just about CPUs anymore, like the only compute. You're getting this specialized hardware. GPUs is one of them. You have your TPU. All the big
Right.
cloud providers are building their own new hardware. Intel is building their own hardware, new hardware. So you're having those hardware accelerators coming into the game, and they need to play with CPUs, right? So you'll have CPUs, accelerators, and how you're using those accelerators, those new accelerators efficiently, and how do you make the best use of them? That's really, really difficult today. That's really, really difficult today. And yeah.
I can see that. I also see this idea of the operating system for your machine learning infra is a nice way of visualizing it. And especially when you're allocating these different resources, how can you make sure that everything is one big family? Your CPUs, your TPUs, your GPUs, they're all very harmonious and you're getting the most out of each one of them. What were you going to say, Vishnu?
I was just going to say,
Yeah.
I have two thoughts here connecting back to previous episodes of ours, right? First off, last week we had on Brandon Dorsey, who was, awesome episode, go listen. But he was talking about the infrastructure sort of management his company does because they do a lot of browser intensive machine learning. But that really led to the point of saying, like, well, there are two companies in this world, or two types of companies increasingly. Either you're a company that spends a lot of time managing infrastructure and you do a lot of custom work, or you don't spend any time. And when I'm hearing you talk about your vision for GPUs, I think it's really important to say, I don't think any company should be doing what you're offering them, right? Nobody should be thinking about their GPU management in the way that you're thinking about it, because it's so low level and so undifferentiated when it comes to a business model for a company like mine, but so powerful to outsource to a managed service like yours. And the second thing is I think a lot of times, like, what we do on this podcast is talk about machine learning and MLOps from the view of companies of today, where at most you have high single digits, tens. Maybe if you're Google, you'll have hundreds and thousands, whatever, right? The Googles and the Fangs, they're totally different. But really, we're moving to a world faster than we think where companies are going to all have hundreds of models running in the background, right? And that's why tools like this are so crucial, because this is going to become a, run-of-the-mill workload. You got something to say there?
Exactly. So, yeah. So, Heis was mentioning it in the beginning, right? So we see problems, right? The things that we discussed right now on the effectiveness of how to use accelerators, GPUs. So we see it when companies approach to us, and they have problems because they have hundreds of data scientists, in some cases more than 1,000 data scientists doing machine learning. They are used to run their notebooks on CPUs. Now, like, how do I provide access to hundreds of data scientists to GPUs, right? In an effective way, in a simple way, without causing them to deal with infrastructure hassles and staying effective with the way they use GPUs. Now it's continuing, right? When they train, like do large scale training, and they need to use a lot of GPUs to train models, like how do you do that efficiently? And then it comes to inference also. It's always not about just deploying one model.
Exactly.
It's always about deploying, multiple models, and it scales up really quickly, typically to tens, hundreds of models. And how do I deploy all of those models on accelerators, and even not on accelerators? That's difficult today.
I would really love if you could walk us through what some of the engineering challenges were as you built Run AI and thought about, hey, how do I leverage Kubernetes, right? You guys love Kubernetes. It's a booming open source project with the challenges of supporting future AI workloads, right? Like, what are the engineering trade-offs, requirements that you need to build towards? Can you talk us through maybe a story of a feature you had to release that was, particularly challenging from an engineering standpoint? I know our listeners would love to learn more about the challenges of building around GPUs.
Yeah. I can mention two big challenges that we started with them. One big challenge was relating to just scheduling in Kubernetes. Just scheduling in Kubernetes. Kubernetes was built on top of Linux, right? And it's the scheduling of in Kubernetes really makes a lot of use in Linux, right? You get like scheduling layers, scheduling hierarchies in Kubernetes. So you have like the cluster scheduling, and the goal of the cluster scheduler is to take pods, containers, and bind them to nodes, schedule them to nodes. But then the Linux scheduler takes that and then schedules containers inside of the node. So you have these scheduling hierarchies in Kubernetes that are built in, right? Cluster scheduling and then a node scheduler by Linux. And then you have that in Kubernetes, but when we examined the problem, we looked on other fields that are really very similar to AI. We looked on the HPC field, high performance computing. HPC workloads are really, in a sense, really similar to AI workloads, like training workloads, but really compute-intensive workloads. They can run for a long time. You also have like experimentation phases there, or it's more like simulation phases there. But we saw what happened in the HPC world. Like for more than a decade, in the HPC world, the new schedulers were developed that were built without that scheduling hierarchies, like cluster scheduling and Linux schedulers. So we saw that. We saw what's happening there, what's needed in the HPC world, and what has been done in the HPC world. We also saw what happened in machine learning in terms of Spark workloads, in Yarn scheduler running on Hadoop. So we saw like machine learning, in a sense, right? Yarn and Spark workloads. A lot of work has been done in Yarn. Amazing project there. So we took concepts from the HPC world and from Yarn and Hadoop in terms of what's needed to schedule training workloads, to schedule AI workloads, to allow a lot of data scientists share clusters and run their workloads, their compute-intensive workloads. So we saw that, you don't want to limit your users to static quotas. You don't want to limit them to, you get 2 GPUs, you get 4 GPUs, you get 8 GPUs. Now, that's not efficient. That's not effective for the researchers, right? They are like, it's a limit, right? It's a hard limit. They cannot go above it, and sometimes researchers need just 1 GPU or no GPU, and sometimes they want to run big workloads on 20 GPUs or run hyperparameter optimizations on many GPUs. So like that flexibility of sometimes using a little bit of GPUs and sometimes using a lot of GPUs is really, really needed. So we took concepts from there really and brought them to the world of Kubernetes. We brought a concept called guaranteed quota. It's really it's really based on concept in Yarn. They have a similar concept there. So we brought guaranteed quota, the ability to not be limited by hard quotas. Just, if I'm a researcher, I can just run all my workloads and even use all the GPUs in my cluster. So guaranteed quota, fairness, things like that. So we built a new scheduler to Kubernetes. I'm going to the end, right? So
Nice.
we saw that the Kubernetes scheduler doesn't fit. You cannot, adapt the Kubernetes scheduler to all that is needed to run AI workloads really effectively. So we've built a new scheduler, and we've built it in a native way to Kubernetes. So it's like we have the software component, our scheduler, that plugs into Kubernetes clusters, and it can run on any Kubernetes flavor, right? It's just really simple to run it. It's just, a pod running in Kubernetes. But the workloads are then being scheduled with our scheduler, together with the default scheduler of Kubernetes. It runs like that. So that, we've built a scheduler that was really fun. We're still building it. It's really, scheduling is complex. So that was fun. Also fractional GPU, that was another really interesting feature that we bought. Like it was, today you can, in Kubernetes, you can request for your workloads only integer number of GPUs. So I can have 1 GPU, 2 GPUs, 4 GPUs. You have no way to request half of a GPU, a quarter of a GPU. And in the CPU world, you have it, right? In the CPU world, you can request half a CPU, right?
Yeah.
A quarter of a CPU. So that was also really challenging in Kubernetes because of those scheduling hierarchies. And we brought that to the game as well, right? So we're enabling fractional GPU, right? The ability to run a container just on fractions of a GPU. And really relevant where researchers are just running their Jupyter notebooks and they don't need a full GPU. Or in inference workloads, it's really, really important, right? In inference, we can dive into that some more, but in inference, not always you need a full-blown GPU. Usually you need much less than that.
So there's something interesting as you explain how you developed this that I would like to dive into, because it feels like you have so many different people that have their hands in the pie, per se, and you have these very low-level engineers that are working on some seriously hard problems down here. And then you have the data scientists or the machine learning researchers or just the machine learning engineers that all have a say, or you're building for them and you want to keep them in mind, or they're also building the product with you. How did that come to be? What was that process like to make sure that the low-level engineers are on the same page as the data scientists and everyone in between?
Yeah, that's a good question. So, when we started, it was really, really important for us to build a simple product, right? A simple product both for the users and the researchers, just in the simplest way for them to run their workloads, right? They don't want to deal with the infrastructure. They just want their workloads to run as fast as possible, right? And quickly. So we brought advanced technology and we tried to wrap it in a product, in features that are really, really simple for users to consume them. So both the engineers, the researchers, but also the admins, the DevOps, the MLOps guys that manages policies around how to share a cluster, how how to use the resources. So also for them. So it was really, we worked really hard on that. We invested a lot of thought on how to simplify things. That's that's really difficult in many times.
And also a never-ending process. Because you can always tweak, you can always make things better, and I think that's a key emphasis we have when developing the product. Is let's make it simple, and then the next step is okay, let's make it simpler, and let's make it even simpler. And like more and more abstraction means better like user experience, and it's all about the user, because maybe the data science teams, they don't necessarily, let's say, buy the product, but they are the users. They are the ones adopting it. They are the ones driving usage. So those are the ones that you need to care about, and of course the ones managing the infrastructure. But it's if there's no adoption, then there's no usage.
And so was there ever the thought of like, how much power do I want to put into the data scientists' hands, and how much should we keep for the others, or for ourselves, or maybe for the SREs at the companies that the data scientists work at? Like, how do you look at that trade-off of it? Do you want everything to be in the hands of the data scientists? Do you want just a little bit? What does that look like?
Yeah, so we wanted to bring as much freedom and as much simplicity to the researchers, to the users. So that's part of what we're bringing, the ability to not being constrained to hard quotas, right? So you just run your workload, run them, use as much compute as you want. If the system has available compute, it will offer it to you, right? So you're not limited. You can run as much as you can, and behind the scenes you have people that need to manage and to keep that everything works well, everything orchestrated well, and everything goes according to plan. There are no problems, and everyone are enjoying, the cluster, and enjoying the compute resources. So you have someone behind the scene, an admin, that that is responsible for that. But you as a user, you shouldn't be aware of that. You should have, as like in the cloud, right? You can consume as much as you want, right? Yeah.
And how do you look at fail safes? Because I've heard some horror stories of some like $40,000 joins that have happened at some companies or things like that. Do you make sure to let people know, like, hey, what you're about to do might cost you a lot of money?
Exactly. We for sure. That's we're helping with that, right? It's like if you're thinking about an A100 server on Amazon, right? An A100 machine, it costs I think $32 per hour, something like that, right? So you leave it open for a few days. That can scale up really quickly. Yeah. So it can hurt.
Yeah.
It can hurt. Yeah. It can hurt. So we're providing ways for admins in that sense to see, like, to manage you and see that people are not going too much above the budget that they can get, right? So then it comes to budget. You don't want to limit them too much, right? In terms of, like, that's your budget and that's it. You cannot use more compute than above your budget. You don't want to do that, but you want to have like a certain level where you're saying, okay, that was too much, right? So we're providing ways to do that as well.
Yeah.
There always needs to be this fine balance between control and freedom within platforms like this. I think one of the key elements which made me very interested in Run AI when I started looking at it before I joined them is the fact that for the data scientists, again, it's a very hands-off approach, because the scheduler it's the fairness algorithm, the quotas, everything's is in place to really make it a hands-off experience. The only thing they need to do is just fire up those jobs, and based on the preset policies and priorities, you'll get your resources. And your training gets done. Maybe it's at night because no one is using a Jupyter notebook, and we can scale off those jobs into CPU memory, and all of a sudden GPUs are available again, and then it will finish at night. So you can still have control while giving the data scientists all the amount of, like, virtually unlimited amount of GPU, because the scheduler will take care of it. And that's part of what, like, part of the limitations of like a regular Kubernetes cluster. It's like one queue. You can easily fool that queue by just firing off loads of jobs and always get your resources when you need it. So that's where the fairness algorithm, that's where the scheduler, the multiple queues, that's where all of that comes into play. So yes, there's a set of control, but still, with that control in place, we still want data scientists to use it as much as they can whenever they can.
Yeah, so that's on the research stage. And then, when it comes to production, right, on taking trained models and move them to production, then the problems are different. We're working with a company that they have more than 3,000 models that they need to deploy on GPUs. Right? So how do you do that? So it's 3,000 models. It's every customer of theirs have something like their own model, or every group of customers have multiple models. And so you have 3,000 models. They need to run on GPUs, but they are not being used all the time, right? They are being used only infrequently, not always, right? Like if I'm a customer of that company, so I'm occasionally sending data, and then the models need to run. So now the straightforward way is to deploy a model, one model on one GPU, right? So then you'll need like 3,000 models, 3,000 GPUs, right? and
gets expensive.
Get expensive, and I'm not sure that you can even, it will be really difficult for you to get it from your cloud provider. 3,000 GPUs, right? So, and you can't really scale down scale down to zero your GPUs, because if it's latency sensitive application, then it needs to be on, because it really, to spin up a GPU node in the cloud takes several minutes. Much more, it's longer than spinning up a CPU node in the cloud, really. It's like until the node comes up and you need to install all the GPU drivers and all of that, it takes like 6-7 minutes to spin up a GPU node. Then when you spin up the server, your model server, it's again like a few seconds, just a few seconds until your model is ready, till you warm it up, and it's ready to serve requests. So in what we see is like scaling to zero is not always possible in many occasions with models. So like using 3,000 models on 3,000 GPUs, always available, that doesn't make sense, right? So you cannot run like one model per GPU. That won't work for you. So now, how do you share models? How do you run multiple models on just one GPU? And there are techniques to do that, right? We can deep dive into that, but really that subject is really, really interesting for me right now, because there's multiple ways of running multiple models on a single GPU. Not all of them work well, but really that's a problem that's really interesting for me today, right?
Yeah, talk to us about which ones work well and which ones don't, because that's probably interesting to hear about.
Yeah, I think there's one approach is to load multiple models to a single server. Like you have your GPUs, you have your compute resources, and then you need like a serving mechanism, right? TensorFlow serving or Torch serve. And those are like serving mechanisms that you load your model, and they can receive requests, and run your model on that. And you can even run a pipelines of models. NVIDIA came out with Triton. So Triton really simplifies that problem. They allow you to host multiple models on the same server. So the ratio is changing. Now it's not just one model per GPU. It's multiple models that can be hosted on one GPU. So we saw that approach. It can work well, but it's like the problem goes to a different places. Like you're starting to orchestrate models when you're doing that. Like you're having, tens of models being hosted in one server. Now you need to orchestrate those models. Things like scaling up your servers. You need to scale up your models instead of scaling up your servers. You need to manage priorities between those models, make sure that one model doesn't starve others. You don't have problems with memory collisions between all of those models. So you're starting to orchestrate models. And you're getting this problem of model orchestration. So Kaiser, for example, it's really an amazing project that tries to solve that. They have this new model mesh. I think it's called Model Mesh project, open source, which tries to deal with that model orchestration problem. Anyhow, that's one approach. We're helping our customers to use that approach. We also allow them to have another approach of just deploying models not on a full GPU but on fractions of GPU. So you can deploy one model in one server and host it on a tenth of a GPU, on a third of a GPU, right? So we allow them to right size their models in terms of the compute consumption.
And does that
So just
does it stay?
yeah, so that's another approach.
Does it stay like you were saying, like you never scale down to zero in that case because it's always there and you don't have that cold start problem?
Yeah, so it's always there. So for one GPU that is up and running, you're hosting multiple models, right? So multiple models are ready, are warmed up, and are ready to receive requests. So now you can have those multiple models being hosted in one server, right? Like the server technology, right? The TensorFlow serving, or Triton enables that. But so you can do that. Another approach is to just deploy one model or a small number of models in one server and then right size the compute resources. Just use fractions of a GPU instead of a whole GPU. So still you have one GPU that you're paying for, it's up and running, and then you have many models that are ready to receive requests using that GPU.
Yeah, that makes sense. So I want to change gears a little bit, Ronen, and ask you about why you think it is there are so many machine learning startups right now coming out of Israel.
In Israel? Okay.
I think more than anywhere else, we've probably had more Israelis come on the podcast and they have their own startups or they're in the community. And it's like between Israel and India, I would say. But I mean, of course, the US has a ton of startups too, but it feels like for the size of Israel, there is such a strong concentration of machine learning and MLOps companies coming out of there. And I'm just wondering what your take on it is.
Yeah, that's an amazing question. So there are a lot of smart people in Israel.
That's the first
Really?
thing. Yeah.
Yeah. a lot of people here in Israel like technology, whether it's machine learning or other stuff. Here in Israel, we're also strong very much in cyber, right? In cybersecurity. There are also a lot of companies here in Israel in cybersecurity, a lot of companies that are really, really successful. So I think that's really, really deep why there are like so many good startups, like technology startups here in Israel. I think, we have the army. Maybe you heard about it. Like
Yeah.
every person in Israel is being drafted to the army. Everyone, when they are 18 years old, they are being drafted for, usually to at least 3 years. And many people are going to serve in the intelligence units. And there is a lot of technology in the intelligence units, a lot of technology. So on the age of 18, those soldiers are going and doing amazing stuff with technology, amazing stuff.
I see.
They are getting like, amazing experience. They learn so much. They're doing really crazy stuff. And then they go out of the army, and usually they start companies.
Yeah.
So my co-founder, my friend, I've been in one of those units long time ago. I'm already 40 years old, 41 years old already. So it was a long time for me ago. My co-founder, for example, he was in the army, and he released, and we started Ronen AI. So many, young people are getting out of the army with amazing experience in technology, really amazing. They're doing, cutting edge stuff, a lot with AI, a lot of things with AI, a lot of things with AI and around cyber. So cyber and AI in the army, they're doing a lot of stuff there. So they're going out with amazing experience, and they're starting companies, and they're doing crazy stuff, really crazy stuff. So that's one thing. Also, the academia here in Israel is really good. I came from the academia. I've been in the academia for many years. So in the academia, we have amazing researchers that are doing amazing stuff in machine learning. Mobileye came from Israel.
Yeah.
Mobileye was started by Amnon Shashua. Amnon Shashua is a professor in machine learning in one of the universities here in Israel. Like, he was really famous in the machine learning ecosystem.
Yeah.
He started Mobileye. And they changed the world of autonomous cars with machine learning. So also the academia is really strong here in Israel.
That makes complete sense. I love hearing that. It is a wild place. I hope to visit one day and check it
Wow,
out
you
because
have to.
there's so many
You need to
great things.
you need to come to Tel Aviv,
Yeah,
Demetrius.
that's
Wow,
it. I'll
you'll
go
enjoy
wild.
Tel Aviv.
But guys that look like me have not the best history in Israel. They don't really make it out alive, especially when I undo my hair and I have the beard. So I've got a joke about that
Yeah,
one that I'll tell for another time. But
okay, but you'll be fine. You'll be fine in Israel.
so there's one thing that I wanted to touch on before we finish off, because I think that it's interesting to think about your vision for the future when you're looking at GPUs, and especially when you're looking at Kubernetes and how Kubernetes is potentially going to advance. Do you see it going to be more GPU friendly, or is it going to be easier to orchestrate GPUs on Kubernetes? I know that there was a hot take that it's like Kubernetes is not really built for machine learning workloads right now. It's not the friendliest. Do you see it changing, or do you feel like that is something, it's your job with Ronen AI, that's what you need to do? You don't see the community, the Kubernetes community going that way in any time soon?
Yeah, that's a good question. So for sure, we're helping with that, right? So everyone who feels like that, then they need to try Run AI for sure. It won't look the same. So cloud native, like I'm a strong believer in cloud native technology, right? In Kubernetes and containers. Like the entire world the infrastructure world is shifting to run on cloud native technologies, on Kubernetes. I love Kubernetes. It's an amazing framework, amazing technology, really. And with time, GPUs will will become, a first-class citizen in Kubernetes. Right now, it's mostly CPU and memory that are, first-class citizens, resource citizens in Kubernetes. GPUs will become more and more important with the years. And it will be also GPUs, and it's also changing. It's not just about GPUs, right? We talked about it, right? Specialized hardware, applications that are really, really important in the cloud will have their own hardware. Time will come, but applications that you have a lot of them in the cloud, you'll get like specialized hardware for them. Right now, it's with AI workload, you're getting GPUs for them, right? So specialized hardware and cloud native, I really, really believe in that. It will come simpler and simpler. In the CPU world, it has been done in the last 20, 30 years. So we have a long way to go. But there's a lot of software that needs to be built. I'm a strong believer. AI, cloud native, and GPUs, a lot of buzzwords, but those things are changing the world right now.
Yeah. And
Sure.
as far as like the future of AI accelerators and GPUs, where do you see that going?
AI and accelerators. So, yeah, we see the trend. We spoke about that. More and more compute to process more and more data, to solve, to build bigger models, to solve more complex models, more complex problems. Let's see to where it can get, right? So, right, OpenAI trained models on how many, like thousands of GPUs?
Yeah.
Like 2,000 of GPUs. What was the recent year? Yeah, so let's see where it goes there. But specialized hardware, models are, all the algorithms needs to be built better. The software layers needs to be built better. So, yeah, there's a lot of work to be done in the AI stack.
Yeah.
It's just starting.
Pure optimization, really, is what it sounds like. So, last ones, I've got a lightning round for you. And I want to know, we'll go through, we'll go like one in one maybe. We'll start with you, Ronen. What was the last book you read?
Oh, the hard thing about hard things, right? So the classic,
Yeah.
right? I started running AI, and then I read it, and then since then I'm reading so much. I'm reading a lot. I'm reading. I realize that reading is so important. These days I'm reading online on everything. But the book that I really, really remember, the hard thing about hard things, really, it was amazing for me. When I started running, I read that book. Ben Horowitz wrote it. It was amazing for me to read it. Really, really, it had a lot of impact on me.
Incredible one about culture and how to run companies. All right, next up, what was the last bug you smashed?
Me personally?
Yeah. Have you? Or now CTOs don't smash bugs. They just tell other people to smash them?
Yeah. Yeah. I wish I could smash more bugs, but yeah.
All right, then. I got one more, which is, how do you want to be remembered?
Oh. Yeah. That's serious stuff, Demetrius. That's not simple. How would I want to remember? I don't know. I want to leave an impact on this world, right? So I want to have impact. Let's see, like, what would be the size of my impact. But I want to have like the largest impact I can.
All right. And now we turn to you. What piece of technology are you bullish on that might surprise people?
That's me,
Yeah.
right?
That's really, yeah.
Wow. I'm a nerd. I'm a geek. I mean, the amount of impulse gadget stuff I buy is insane. So I can tell you what I'm really passionate
Yeah,
about.
let's hear it.
And that's home automation.
Oh,
Trust
nice.
me, it drives my girlfriend nuts. But like the amount of automation and crazy things you can do with that. Like I use AI even,
All right.
right? I use
Tell us.
computer vision
What-
to
yeah, what have you
recognize
been doing?
cats on my driveway
Oh.
and flash the light as soon as that happens. It's I think I'm very bullish right now on home automation and making life easier at home and doing cool stuff with it.
All right.
And sometimes stupid stuff.
Yeah. Well, I've always watched the YouTube videos on that, and or I should rephrase this. I've yet to see anything that makes me think, oh my God, I got to go out and buy that. It's going to change my life. What have you put into your house that you're like, this one is worth all the money?
Oh, that's my video doorbell because I work from the attic and I work from home and I have kids and I have a lot of neighborhood kids and when they're not at home, they ring the doorbell like 17 times. Now I just watch it. Oh, okay, I don't have to answer that one. Saved me it saved me a lot of steps. It also limited me in physical movement, but that was like the thing that I love that thing.
Oh, awesome. All right. Mr. Marketer, what was the last piece of ML tooling or MLOps marketing that made you roll your eyes?
Ooh.
It could be something that your team tried to get you to put out too. Don't feel like you need to.
No, I think the last time it's typically, and now that I'm closer to artificial intelligence, machine learning, and those kind of things, I tend to roll my eyes a lot of times in the tech industry where they say we use artificial intelligence to solve this issue, where honestly it's not. And that happens a lot of times across the tech industry because like Ronen just mentioned, it's like buzzwords. So that's when I roll my eyes most of the times, especially now that I'm closer to AI and closer to ML. I came from a different world. I came from a data protection world where I blocked many attempts to mix machine learning and artificial intelligence into the messagings where I said, we can't do that. I think more people should take a step back and look at it and think, we can't really say that.
Fellas, this has been an excellent conversation. I thank you so much for coming on here and enlightening me to really the GPU paradigm, we could call it. Maybe that's a strong word. And using Kubernetes to orchestrate things, but Kubernetes and GPUs, where the hangups are. So many good points. I wore my Run shirt. It's not Run AI, but it is Run Nashville. And I wanted in memory of you. Thanks again for coming on here, doing this. Thanks for all your support in the community. It's awesome having you all around. And we just put out a blog post too. So if anyone would like to check out the blog post that we wrote, it's been getting all kinds of attention today in Slack. Feel free to go to the MLOps community blog and you'll see it there. And that is it. We'll see you all later.
Thanks a lot. Thanks for having us, Demetrius.
That was fun.